Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class, let's go for continuing the chapter motion. In yesterday's class, we learned two important concepts. One is acceleration, second one is graphical representation of motion. Let's go for recalling these two first. Then what is acceleration? Yes, it is the rate of change of velocity, or it can also be defined as the change in velocity of a body in unit time. Then what is the formula used to find out acceleration? It is A equal to V minus U by T, right? Then here what do you call U? It is initial velocity. V, final velocity. Then what does V minus U indicate? It is change in velocity. Then what is its SI unit? It is meter per second square, right? Then what do you call the negative acceleration? It is deceleration or retardation. Formula is same and even the SI unit as well. Clear up? And there are two types of accelerations. One is uniform acceleration and second one is non-uniform acceleration. A ball is thrown vertically upward and it starts falling towards the ground due to gravitational force of the earth. Whether it is an example for uniform or non-uniform acceleration? Yes, you are right, it is uniform acceleration. Then what is the definition of it? It can be defined as when a body moves along a straight line, if it changes its velocity by equal amounts in equal intervals of time, then it is called uniform acceleration. And another example, that is a boy riding a bicycle in the crowded area, or else a car is moving in the crowded area. Obviously is an example for non-uniform acceleration. Then recall the definition of it. Yes, when a body moves along a straight line, if it changes its velocity by unequal amounts in equal intervals of time, then it is called non-uniform acceleration. Okay. And one more thing, just we had got the brief information about the concept called graphical representation of motion. The motion of an object can be represented by two ways in case of graph. They are, one is dt graph and second one is vt graph. Then what is dt and what is vt? Here I have written the definition. Yesterday I had told you that. Just to recall, a graph which is obtained by taking time along x-axis and distance along the y-axis is called distance time graph. Clear up? Next, the graph which is obtained by taking time along the x-axis and velocity along the y-axis is called vt graph. So I have written the definitions of these two. You will have to copy later. Afterwards I will give you time for copying that. Now let's move on to today's concept. In today's concept, we are going to get the detailed information about dt graph as well as vt graph. Then you just go through that dt graph, distance time graph. Could you tell the physical quantity which is related to distance time? Yes, you are right, it is velocity or speed. In case of graph, we consider distance and displacement as same and velocity, speed as same. Do remember that. Now, if it is so, you have to get the velocity by distance time graph. Now, it can be asked in the examination. I'll write it in the form of question like this. Show that the dt graph gives, distance time graph gives, what does it give? Yes, it is velocity. Then how? Now, let me go for explaining it. Observe this carefully. I go for drawing the dt graph of a body moving with uniform motion. See that this is x-axis and I am going to draw the vertical line called y-axis. Here, x-axis and is y-axis. Both will intersect at a point perpendicularly. Call this as origin and represent it with the symbol O. Then a body is covering equal distances in equal intervals of time. Just I am going to draw the line like this. Okay. Now I am going to take a part of this graph. Call this point as A, this point as B. Then go for drawing the perpendicular line from A to x-axis and B to again x-axis, which intersect the x-axis at two distinct points. You may call this as C and D. And as it is time axis, so you can call this point as T1, this point as T2. Next, again, draw the line parallel to x-axis through A. It will intersect the point BD at a point. Call this as G. And again, here I will draw one more line. A line drawn parallel to x-axis through B. These two lines will intersect the y-axis at two distinct points. You may call it as this as E and this as F. And it is distance axis. I call it as this is S1 and is S2. Now here we have got the triangle. Can you identify the triangle? Yes, it is AGB. Then what type of triangle it is? It is a right triangle. Now let's go for finding the slope of AB. Then what is slope? S-L-O-P-E. S-L-O-P-E. What is slope? It is the ratio of vertical distance to the horizontal distance. Then I can write the slope of AB as BG by AG. So BG by AG. What is BG? BG is, see that this distance. What is the distance from E to F? It is from here to here, S2. From here to E, S1. To get this distance, you have to subtract S2 in, you have to subtract S1 in S2. Hence I can write it as S2 minus S1. Alright, S2 minus S1. And AG, you want to get this distance, that is CD. OD minus OC. OD is T2. OC is T1. So T2 minus T1. What is S2 minus S1? It is just S. T2 minus T1. It is T. What is S by T? Yes, it is V, nothing but velocity. So slope of AB is velocity. Hence we can write that dt graph gives velocity. So can be given for 2 marks. Got it? Now you have to copy from there to here, and you will have to write some of the points. What you have to write is AB. What is AB? It is a part of the dt graph. Then second point, draw AC perpendicular to x-axis and BD again perpendicular to x-axis. Next, draw a line EG parallel to x-axis. Draw EG parallel to x-axis through A. Then, and FB parallel to x-axis through B. Then mark the point G. Then after that you have to copy up to here. Yes, copy that. Okay, dear students, just we have come to know that the slope of dt gives velocity, or distance time graph gives velocity. But here I have taken Vt graph. Could you tell which physical quantity is related to velocity and time? Yes, you are right, it is acceleration. Then if it is so, can we say that the graph of Vt gives acceleration? Yes. Now let us come to know how this is. Even it should be written as a question. Here I will write. Show that Vt graph gives acceleration. Can be given in the examination for 2 marks. Here I have drawn Vt graph. Time is taken along x-axis and V is taken, that is velocity is taken along y-axis. I am going to take a part of it, just like in previous one. A part of graph of Vt is AB. Here I will write. Consider AB is a part of Vt graph. Okay. Now, let us go for drawing the perpendicular from A to x-axis, again from B to x-axis. Let me draw that. Then these two perpendiculars will intersect x-axis at 2 distinct points. I call this point as C and this point as D. And time O to C, the time taken is T1. O to D, it is T2. Let me write that. Draw AC perpendicular to x-axis and BD perpendicular to again x-axis. And one more point. Let me go for drawing again a line, perpendicular line from A to y-axis, or else perpendicular parallel line to the x-axis through A. Here I draw that. And one more line, parallel line to the x-axis from the point B. These two will intersect at a point, call it as E and this as F. And here V is there. I call the point E as initial velocity and up to F as final velocity. Got it? Okay, now here I will write. I call this point as G. Let me draw EG parallel to x-axis. Through which point? Yes, through the point A. And FB parallel to x-axis. Through the point, another point, what it is? Another point B. Then the point G is marked. So mark the point G. Now, observe. Here also I go for taking a triangle. What is the triangle? It is AGB. Again, what type of triangle? Right triangle. Then let us go for taking slope of A. Slope of AB. Just I told you, slope means the ratio of vertical distance to the horizontal distance. Vertical distance is BG and horizontal distance is AG. Then what is BG? The distance of BG from, that is E to F. O to F is V. O to E is U. Hence, EF is V minus U. Can we write so? Yes. It is V minus U. What is AG? AG is equal to CD. Then O to D, it is T2. O to C, it is T1. Now, I can write this as T2 minus T1, which is equal to V minus U by T2 minus T1 is, it is just T. Then could you tell what does V minus U indicate? It is change in velocity. T indicates time. Change in velocity in unit time is what? It is acceleration. Now I can write slope of AB gives acceleration. Hence conclusion can be written as, therefore VT graph gives acceleration. It is also an important one. You must practice this. In the examination, the same question can also be asked in another way, as show that the slope of VT is acceleration. Got it? Or else show that VT graph gives acceleration. These are the two different ways the question can be asked. Now with respect to both, that is DT graph gives velocity, VT graph gives acceleration. From these two graphs, we can go for writing some of the conclusions. Now let me go for telling you what are these conclusions. Conclusions are very important. I'll go for explaining one by one. Before that, you have to copy from there to here. Please write it as a heading as a question. Without fail, you have to draw the graph, then write the related terms, then go for taking the slope and write the final conclusion. Okay, pause the video and write up to here. Dear students, just we have come to know about DT graph as well as VT graph. Now let us go for drawing some of the conclusions with respect to both. Just here I have drawn only X and Y axis. Here in first part, look here, these four graphs are related to DT graph, because I have taken time along X axis and distance along Y axis. Look here. Here, this is the point, initial position of a body. At 0 time, it is at some distance. Now, after some time, it may be 1 second, 2 seconds, 3 seconds, the body position will be here. And after 2 seconds, the body position will be here. And after 4 seconds, 5 seconds, see that in every interval of time, what is the distance of the body, whether it is same or different? No. Yes, it is same, right? Then I go for joining these points. Look here. The distance at which the body is present is same in all intervals of time. That means the body is not at all moving. Look here. Assume that I am at a distance of just 2 meters from this point. After 1 second, am I covering any distance? No. After 2 seconds, count. 3 seconds? No. Why? I am in the same position. So you can say that this is the DT graph of a body at rest. This is first one. When a body is at rest or stationary, the graph will be like this. Next, I go for taking second. This is second one. Observe it. This is initial position of a body. After 1 second, it comes to here. 2 seconds, it comes to here. Observe the distance being covered by the body. Will it be same or different? It will be covering unequal distances in equal intervals of time. When a body covers unequal distances in equal intervals of time, then we say that it is moving with non-uniform velocity, right? So we can write this as non-uniform motion or non-uniform velocity. Non-uniform velocity. Next, here again, after 1 second, assume that a body covers a distance of 2 meters. After 2 seconds, it covers 4 meters. After 3 seconds, it covers 6 meters. That means here the body is covering equal distances in equal intervals of time. So when a body covers equal distances in equal interval of time, then it is called uniform motion or uniform velocity. So uniform velocity of a body, its graph will be straight line. It is uniform velocity. Followed. Then here just observe this straight line. It indicates that if it is straight line, it is uniform. But here decreasing the distances. Hence we can say that it is negative uniform velocity or uniform negative velocity. Here I'll write fourth one. Uniform negative velocity. So these are the four important graphs with respect to dt. The first one is the line is drawn parallel to, in case of dt, if a line is drawn parallel to x-axis, you can say that it is the graph of a body which is at rest. Then if it is curved line, then you can say that the body is moving with non-uniform velocity or just non-uniform motion. Next, third one. Here the body is covering equal distances in equal intervals of time, so that it is a straight line. Hence you can say that it is the graph of uniform velocity. Whereas in fourth one you can come to know that it is a uniform negative velocity. Clear? These are the four conclusions. The same thing can also be applied here as well. That is conclusions of VT graph. I take the time along x-axis and velocity along y-axis. Here this is VT graph, this is VT graph, and here also VT graph and VT. Total 6 are there. Now just look here. For the sake of understanding only, I am marking some of the points. You can call each point as 1 unit. This is 1 second, 2 second, 3 second, 4 second. Here 2 meter per second, here 4 meter, 6, 8, 10, like that. Now at 0 time, the body is moving with some velocity. See the 2, 4, 6, 8. The speed of the body is 8 meter per second. Then after 1 second, what is the velocity of the body? Again 8 meter per second. After 2 seconds, again 8 meter per second. After 3 seconds, again 8 meter per second. So it is all the intervals of time, the speed is same. Then you can say that the body is moving with constant velocity or uniform velocity. Okay, just compare in dt. If the line is drawn parallel to x-axis, it is the body at rest. And here in case of vt, if the line is parallel to x-axis, then you can say that it is uniform velocity or constant velocity. Next, here second one, just observe. Here also I am going to mark some of the points. 1 second, 2 seconds, 3 seconds, 4 seconds. Here 2 meter per second, 4 meter per second, 6 meter per second and 8 meter per second. Look here. When the body is at rest, what will be the velocity? It will be 0. In 0 time, the velocity is 0. After 1 second, the speed of the body, observe how much it is, 2 meter per second. After 2 seconds, what is the velocity? 4. Then after 3 seconds, the velocity of a body will be 6. Then observe. Now look here. We all know that VT graph gives acceleration. You can come to know that change in velocity in unit time. In every unit time, the change in velocity is same. Look at within 1 second, the body has changed its velocity from 0 to 2 meter per second. In the next second, the body has changed its velocity from 2 to 4. That means again 2 seconds. You can say that the change in velocity of a body in unit time is acceleration if when a body moving along a straight line, if it changes its velocity by equal amounts in equal intervals of time, then it is called uniform acceleration. Here, so this straight line indicates uniform acceleration. Observe. Next, I'll move on to third. Look here. Here again I go for taking, I'm going to mark the points which represents the time here on the time axis. 1 second, 2, 3, 4, 5 like this. Here 2, 4, 6, 8, 10 meter per second. Look here. In 0 time, the velocity of a body is 0. Then in 1 second, the velocity of a body has come to 2 meter per second. In 2 seconds, the velocity of a body all of a sudden it has been increased to 6 meter per second. Then in 3 seconds, the velocity of a body comes to 8 meter per second. Now I am going to join this. What you got? You got a curved line. Then what does it indicate? Here, do you say that the change in velocity of a body is equal in equal intervals of time? No. Look at in first 1 second, it has changed its velocity from 0 to 2 meter per second. Whereas in next 1 second, it has changed its velocity from 2 to 6. That means there is change in velocity is 4 meter per second. Here the change in velocity is being changed continuously. Hence we can say that the body is moving with non-uniform acceleration. So here I'll write non-uniform acceleration. So in general you can say that in VT graph, if it is curved line, it is non-uniform acceleration. In VT graph, if it is a straight line, then it is uniform acceleration. In VT graph, if the line is parallel to x-axis or time axis, then it is constant velocity. Now just observe here. Again I go for taking one more. 0, this is 1 second, 2 seconds, 3 seconds, 4 seconds. Next here, 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second. Now at 0 time, already the body is moving, its velocity is 8 meter per second. Now after 1 second, the body has reduced its velocity from 8 to 6 meter per second. After 2 seconds, the body has reduced its velocity from 6 to 4, like that. See that here it is, the velocity is being decreased. Is it by equal amounts in equal intervals of time? Yes. So then what you can say that when a body moves along a straight line, if it changes its velocity by equal amounts in equal intervals of time, it is uniform acceleration. If that change in velocity takes place by equal amounts in decreasing form, then it is negative acceleration. Then can we say that it is uniform negative acceleration or deceleration? Yes. Here I'll write fourth one, uniform negative acceleration. I go for taking one more graph. Here, fifth one. Observe. Now again 1 second, 2 seconds, 3, 4. Here 2, 4, 6, 8, 10. Now the body at 0 time, the speed, what is the speed of the body? Look here, 2, 4, 6, 8, 10. What is the velocity of the body or speed? It is 8 meter per second. In 1 second, it has changed its velocity from 10 to 8. Then in the next second, all of a sudden, it has come down to 4 meter per second. In the next one, it has come to 2 meter per second. In the fourth second, it comes to 0 meter per second. That means the body is decreasing its velocity from 10 meter per second to 0 meter per second. If you go for joining these points, you will get the graph like this. Here, what is it? Here, whether the body is increasing its speed or decreasing its speed. It is decreasing. Then can we say that it is the graph of non-uniform deceleration or non-uniform negative acceleration? Yes, alright. It is non-uniform deceleration. Deceleration is nothing but negative acceleration. Negative acceleration. Now, let us come across one more. Look here. It is sixth one. Just I draw a straight line like this. What does it represent? It is uniform acceleration. Then this is uniform deceleration. Clear? So here both are there. Uniform acceleration and uniform deceleration. First uniform acceleration and second uniform deceleration. Uniform deceleration. I hope that you all have understood this. Once we shall go through all these conclusions. Okay, in this, these are all dt graph. Here, when in the dt graph, if a line is drawn parallel to x-axis, it is you can say that the body is at rest. If a body is covering unequal distances in equal intervals of time, it is non-uniform velocity or non-uniform motion. Next, if a body is covering equal distances in equal intervals of time, then you can say that it is uniform velocity. Then, next, here the body is decreasing its displacement, then you can say that it is uniform negative velocity. Come to VT graph. In VT graph, if the line is drawn parallel to x-axis, it is the body is at constant velocity or uniform velocity. Second one, here there is change in velocity by equal amounts in equal intervals of time. It is uniform acceleration. Then change in velocity by not equal in equal intervals of time. It is non-uniform acceleration. Here the decrease in change in velocity by equal amounts in equal intervals of time. It is uniform negative acceleration or uniform deceleration. Then here you can come to fifth one. Here you can come to know that there is decrease in the velocity unequal in equal intervals of time. Hence you can say that it is non-uniform deceleration. And here you can see both uniform acceleration and uniform deceleration. Clear? So now you have to pause the video and please copy from there to here. Yes. Dear students, just with respect to dt and vt, I go for drawing a graph, immediately you just recall what are these. Okay. Could you tell what type of graph it is? It is dt. Then what does this graph indicate? It is uniform velocity or uniform motion. And this is non-uniform motion or non-uniform velocity. And this is uniform negative velocity. This is non-uniform negative velocity. Then I go for drawing a straight line. Then what does it represent? It represents the body at rest. Let me go for taking again one more, that is VT graph. What does this straight line indicate? It is uniform acceleration. Clear? Then this is non-uniform acceleration. And third one, see that, non-uniform deceleration. Uniform deceleration. This is constant velocity. Followed? Okay. Now, again you have to observe one more graph. Here I draw, and even it was given in the examination as well. I am going to draw the same. Look here. Here I have drawn the horizontal line, which is called x-axis. I go for taking it as time, and vertical line is called y-axis, call it as v, that is velocity. So it is the figure with respect to VT graph. And just keep observing. Here I am drawing some of the lines, horizontal line, and here is slant line. Again one more slant line. Let me start from here. I call this point as A, this point as B, this as C, it is D, and is E. Could you tell what does AB represent? AB is uniform acceleration. See that here we have taken VT graph. VT graph gives acceleration. Then BC. Then here the body is moving with a constant speed. Which part represents that? It is BC. So BC is constant velocity. What about CD? Again it is uniform acceleration. DE, it is uniform retardation. So in the examination the question will be given like this. Giving you the graph, they'll ask you the question, what do the following represent? Following represent. So this is first one, AB, and second one, BC, third one, CD, and fourth one, DE. So you will have to write the answer. Okay. So you have to copy this graph, then go for answering these questions. Clear up? Now we will move on to the next part of the chapter. Copy that. Okay. Dear students, here we have two more important concepts. Observe carefully. So even these were given in the examination as well, but I have not written the question completely, because you are only going to tell, you are going to complete those questions. See. Show that area enclosed by VT graph under dash. Here, just by observing the graph only, you can come to know that it is VT graph. VT graph. Then could you tell what does this line parallel to x-axis indicate? Yes, you are right. It is constant velocity. It is a VT graph, right? Then area under, see that, area enclosed by VT graph. Just I have taken the area. A part of it is taken, it is AB. Then I have drawn perpendicular AD to x-axis, BC to x-axis. Clear up? I have got this part which has been enclosed. Then what is that? ABCD. Then could you tell Which figure does area of ABCD indicate? It is rectangle. Here I'll write. Area of ABCD is equal to, what is area of rectangle? It is length into breadth. So, what is the length? Length is DC. What about the breadth? Breadth is BC. Right? Then it is equal to, what is BC? BC is, see, O to C and O to D. OC minus OD, it is DC. Hence we can write T2 minus T1. So T2 minus T1 is DC. What about BC? BC is nothing but DA. See this much. From O to V, here U is there at O, then here is V. So this distance will be V minus U. Alright, V minus U. Then it is equal to, here T2 minus T1 can be written as just T only. V minus U. What is the initial velocity? It is 0. Here final, it has some velocity. With that velocity only the body is moving. Right? So I can write 0 in place of U. So it is just V only because U equal to 0. Then this is equal to Vt. What does Vt indicate? So you have to recall the formula. V is equal to S by T. Then we want Vt, cross multiply. Vt equal to S. What does S represent? It is displacement. Clear up? So hence we can write the question as, show that area enclosed by Vt graph under what? Constant velocity. Under constant velocity is what? Just you have come to know, is displacement. So this is the question to be asked in the examination. Show that area enclosed by Vt graph under constant velocity is displacement. So what you have to do? You have to draw the figure like this, x-axis, y-axis, and show the constant velocity and take a part of it. That should be written here. Consider AB. What is that? AB is a part of Vt graph. Or AB represents constant velocity. AB is a part of Vt graph. Then after that, draw AD perpendicular to x-axis. Draw AD perpendicular to x-axis and BC perpendicular to again x-axis. Here, then shade the part ABCD because they have given area enclosed by Vt graph. So shade ABCD. Now next you have to continue from here to here. We know that area enclosed by Vt. So ABCD is a rectangle. So rectangle length into breadth. Then length is taken. It is T2 minus T1 and breadth is taken V minus U. It will be V. T2 minus T1 is just T and V minus U is just V because U is 0. Then T into V can be written as Vt. Vt is equal to S. The reason is V equal to S by T and S equal to Vt. So conclusion, therefore area under Vt graph is, it is displacement. Therefore area under Vt graph is displacement. Displacement with respect to what? Constant velocity. Okay. Now let's move on to another one. Just observe it. Show that area enclosed by Vt graph under what? Just by observation only, you will be able to tell that the nature of the graph is straight line with respect to Vt. What does straight line indicate? It is uniform acceleration. So here I write, show that area enclosed by Vt graph under uniform acceleration is what? That is to be found out now. Now, let's go for that. Here I write area of, what is that? Area under this, I have taken AB as a part. Then from A, I have drawn perpendicular line, AC and BD. I have enclosed it completely. Now, here I write ABDC. Area of ABDC, it is equal to, now could you tell what is the shape of ABDC? It is a trapezium. What is the formula used to find out area of trapezium? Area of trapezium is, it is h by 2 into sum of parallel sides. Then what is the height here? See the AC and BD, these two are parallel lines. What about the height? Height, it may be CD, it may be AG. Got it? I go for taking AG as height by 2 into sum of parallel sides. Parallel sides are AC and BD. AC plus BD, which is equal to, what is AG? AG is observed. AG is nothing but CD. CD, from C to D is, it is T2 minus T1. Here I will write T2 minus T1 by 2 into, what is AC? Look here, from C to A, this distance, it is U, plus B to D, from here to here, it is V. It is equal to, what is T2 minus T1? It is T, just T by 2 into U plus V by 2 is there. Here I'll write it as T into U plus V by 2. You just recall that. What does U represent? It is initial velocity. V represent final velocity. 2 represent, divided by 2. Then it is the formula of which physical quantity? The arithmetic mean of initial velocity and final velocity is, it is average velocity. Hence I can write T into VEV. Then just average velocity, just you can consider it as V. What is VT? Again, VT is nothing but displacement. I can write S. What does S represent? It is displacement. Hence we can write it is displacement. I hope you have understood that once you go through this. This is actual question to be given in the examination. Just to make you to tell the answer, I have done all this. The question is, show that area enclosed by VT graph under uniform acceleration is displacement. After giving this question, you have to write. First, you have to draw this figure. X-axis, nothing but time axis. Y-axis, nothing but, it is velocity axis. Y-axis. Then, draw a line which represents uniform acceleration. Take a part of it, call it as AB. Draw AC perpendicular to x-axis, BD perpendicular to x-axis. Here I go for writing the same. Consider AB is a part of VT graph. VT graph of uniform acceleration. You can write like that also. Then draw. What we have to draw? Draw AC perpendicular to x-axis and another one BD perpendicular to again x-axis. Next, draw a line AG parallel to x-axis. You may call it as E and this as F. For writing it will be helpful. Draw EG parallel to x-axis and parallel to x-axis through A, and FB parallel to again x-axis through which point? B. mark the point G, or you may not also, it is not necessary. Let me go for removing that. Next, shade the part. What is that part? See, area under VT graph of uniform acceleration. See that this is the uniform acceleration, area under that. I have taken the part AB, just below that I have shaded it. So, shade, you can write A, B, D, C. Shade A, B, D, C. What does A, B, D, C indicate? It is trapezium. You can, in bracket you can write trapezium. Then, after this, you can write from here. Area of ABDC, as it is trapezium, height by 2 is equal to sum of parallel sides. And AG has been written T2 minus T1, and AC has been written AC. It is U, then BD, it is V. Next, T2 minus T1 is T by 2, U plus V. U plus V by 2 is nothing but VAV. That VAV into T is nothing but displacement. Therefore, conclusion can be written as area under VT graph of uniform acceleration is displacement. Followed. So that is area under VT graph of constant velocity is displacement, and this is area under VT graph of uniform acceleration is displacement. Both are important. Please do practice. Okay. Now, before concluding the class, let me tell you one thing, dear students. Today we have discussed about VT graph as well as DT graph. We have come to know the conclusions with respect to DT. Total 4 conclusions and 6 conclusions with respect to VT. After that, these two have been proved. That is, area under VT graph of constant velocity is displacement. Area under VT graph of uniform acceleration is displacement. Please practice both of them as many times as possible till you be perfect. Okay. So, you have to pause the video and should copy from there to here. Now, with this, let me conclude the class. Again, I have been reminding you, whatever we have done today, please practice at least 2 to 3 times, so that it will be much easier to solve numerical problems on these. Okay, with this, let us stop the class. Thank you.